Hello and welcome to the section 4.1 lecture today for Algebra 1 Part 2. I want to get a couple definitions out there. We are talking about more geometry stuff, and I'm actually going to, I hate to break it to anybody, but I've actually recorded this video once already, and it just didn't like me, so we're going to try to do better this time. I'm going to need a calculator handy, so I'm going to put it on there for us to see. So to start, surface area, kind of like perimeter. Okay, it is the area outside a shape. Whereas the volume is the space inside a shape. Okay, and then a prism is a 3D 3D shape with congruent bases. And I'll talk about what I mean by that in just a second. Okay. Just to get an idea of surface area and volume, kind of the difference, I think of surface area as sort of outside a shape and I'm painting it. Okay, how much paint does it take to cover this figure? Whereas volume, I think of, I'm going to fill it up with water. Okay, and now for prisms, when I'm talking about they have concurrent bases, that means that we have two sides on opposing sides that are the exact same. Okay, most of prisms that we see, most of the ones that we're going to see are rectangular prisms. And so we kind of have a choice of what we want to look at as the base. So on this one, I'm going to look at what we would typically think of as the base. And then across from it, directly across from it, is another base. So I'm looking at this piece down here and this piece up here. Okay, and it's kind of hard to denote anything on here, but we really need to. Now, I'm going to talk about decomposing a solid into its net. That basically means unfolding it. Okay, I'm unfolding it to try to figure out how to find surface area. We're going to find as we get later on in this, volume's the easy one. Okay, volume is definitely the easy one. Surface area is the tough one, so we need to do some work on that. So I'm going to take this box and basically set it on its side where my bases are on the outsides, and I'm going to lay those outsides apart. I'm basically cutting along most of the lines that I have here and just unfolding it, okay? So I'm going to lay those two bases here and here. Okay, and they're both 11 by 16. They're rectangles. So we've got 11 on the short side, 16 on the long. I don't know if that's really to scale, but that's okay. Okay, now, if I fold those out, I have like two sides and then kind of a tube, rectangular tube a little bit. And if I cut one of those sides that's right along this base, say I cut this side right here, and then unfold this thing all the way around, which is kind of confusing to look at, but if I think about doing that, then I've got this piece here. I might actually unfold it the other way, I guess, based on how I've drawn this, but that's okay. I've got this piece here that refers to this one. Okay, that's this piece right here. So it is 20 by 11. Right, so this edge is 20. Okay, and then this is only going to get uglier. And then I've got my next piece that's 16 by 20. So it's a little bit bigger. Okay, that looks like more like 20 by 20. Try to be a little bit to scale. Okay, so this one is 16 by 20. And then I have this kind of front left piece that I see here. That's another 11 by 20. And then I have another 16 by 20. All right. Now, to figure out surface area, one of the most common formulas that we use sort of the base formula a little bit is that surface area is equal to the two bases. That's these ones. These are my bases. So we would say 2b plus the lateral area. This is a very informal formula. Okay, lateral area being this entire space here. This entire area right here. But how do we figure out what that lateral area is? Well, what on this picture, now let me clean up the picture a little bit. I know, we're freaking out about it. What does it look like this? So one of the sides is 20. Well, that's this side here. So one of the sides of this blue rectangle is 20. And the rest of it, if I think about what that rectangle, what this rectangle looks like in this three-dimensional shape, it looks like this. Oh boy, I missed that a little bit. That's okay. Okay, if I just think about it being a blue rectangle, all the lines that I have drawn here are the same lines I have here. Okay, where specifically, let me look at this, see if this helps. This top edge, nope, that doesn't help. Let's get a little thicker here. And let's go with that purple. This top edge right here is the same as this edge right here. So what could we say that is? Well, that's the distance around the top. What do we use for talking about distance around a two-dimensional figure? We use the idea of perimeter. So this top piece is the perimeter of the base. All right, so that's the perimeter of the base. And then this 20, what I really want to think of as I have this as one base and down here is another base, I want to think of that as like a three-dimensional height, okay, or a distance between the two bases. So a better formula that we like to use for prisms, 2 times the area of the base plus the perimeter of the base times the height, okay, or the distance between the two bases. Let's go ahead and put that to work. Now, I want to find those three things before I just go trying to plug things in and all that. So I want the area of the base, capital B stands for area of the base. Let me actually put these here. This is area of base. This is perimeter of base. And I'm just going to call this the height. Okay, but height has to be the distance between the two bases. So I want to find those three things before I get started at all. Okay, and in a rectangular prism, we have to figure out which one we want to call the base. Let's go with the one that they have highlighted with right angles. Let's go with this kind of back one. Might not be the one that you first picked, but that's okay. I'm going to call that back one the base, and then this front one the base. Okay, so that back one looks like it's 8 by 8. Okay, so the area of the base is 8 times 8 because it's a rectangle or a square in this case. 8 times 8 is 64. What about perimeter of the base? 8, 8, 8, 8. 8 times 4 is 32. And then the height, the distance between the bases. Okay, this one's the height, and that's 10. So for surface area, we have 2 times the area of the base plus the perimeter of the base times the height. Just to check, 2 times 64 feels like 128. 32 times 10 is 320. So we'll add on a 320. And I get 448. And those are meters, and that's a squared measurement. Because again, it's the amount of paint that I need to cover that shape. Okay? Maybe on this next one, we go with the more traditional, what we would think of as the base being, base means bottom. But we have to get that out of our mind eventually, but we can still use it here. Okay, this one doesn't really look like it's to scale. It's kind of weird looking. Seems to be a lot of conflicting numbers along here. But it looks like if I look at this as the base, it is 12 miles by 6 miles. That's just like what do I want to call it? Kind of a visual thing. Just the way that it's angled makes it look like more like a square on the top. But it's actually a pretty big, pretty skewed rectangle, right? It's got one side that's 6, the other side that's 12. So I want to find the area of that base, the perimeter of that base, and the height between the bases. Area of that base is going to be 6 times 12, which is 72. Perimeter of the base, 12, 6, 12, 6. 12 and 6 is 18. 18 times 2 is 36. Some quick math there. And then the distance between the bases is another 12. Okay. All right, so let's go ahead and find our surface area. 2 times the area of the base plus the perimeter of the base times the height. 2 times 72 is 144. 36 times 12 is something big, 432. And when we add 144 to that, we get 576. And those are miles squared. Okay. Now those two were rectangular prisms, or even square prisms if you look at it that way. In that we got the opportunity to choose what our base was. This one we don't have the option. Whenever I have a shape that's not a rectangle, I have to choose that as my base. So on this one, it's going to be the triangle that's on the bottom and on the top. Those triangles are 6 yards, 8 yards, 10 yards. You have to visualize where that other number comes from. And so area of the base is 1/2 base times height. So now we have a base within a base. That's okay. You just got to track which one you're talking about. So right now I'm kind of thinking about the base of the triangle. Maybe I call that the 8. So 1/2 times 8 is 4, times the height perpendicular to the base. I had 4, and 4 times 6 is 24. So we get 24 for that area. For the perimeter, I have 6 plus 8 plus 10. 6 plus 8 is 14, plus 10 is 24, and the height is 7. So I've got surface area equals twice the area of the base, 24, plus the perimeter of the base. Oh my goodness. I can tell my frustration with already having done this. Times the height, which is 7. 2 times 24 is 48. 7 times 24 is 168. 168 plus 48 sounds like 216. And those are square yards. Again, I'm going to test you on the proper units, whether they're squared or cubed. We're going to get to cubed once we get to volume. Next one, we've got a regular hexagon as our base. So if I'm looking for the area of the base, it's going to be 1/2. If you remember this, that's bonus points. Apothem times perimeter. Now here's the tricky part. I need the perimeter twice. I better find that. 6 sides of 12. They're all 12. So that's 6 times 12, which is 72. To find the area of the base, it's that perimeter, 72. We might as well times the 1/2. And then times the 10.4 apothem. we get 374.4. The height between the bases is 5. So our surface area, twice the area of the base. This one's going to get to be a pretty big number. That's okay. Plus the perimeter of the base times the height. Let's figure it all out. We've got 2 times 374.4 plus, I'm going to throw some parentheses in there so I don't have to do multiple problems. That figures that part out, and that gives us a final answer of 1,108.8 square kilometers. That is a huge surface area. Okay, but a big surface area because of the size of the base. Okay, all right. Let's go on to the next page. We're going to take a look at volume. Okay, finding volume of solids. We want to find all the 1 by 1 by 1 cubes that fit inside this thing. So if this thing is 1 mile this way, 2 miles this way, and 2 miles this way, we could actually, kind of plot this one out. If I think about it, there's only 2 cubes that fit going this way. So like there's one of them. And that's going to kind of overlap on itself, but that's okay. So there's one of them right there. That one should be dashed. We can't see it. And that's what dashed lines mean in three-dimensional drawing. Mean that you can't see that side. Now technically, we might not be able to see this side even, but that's okay. Okay, so there's one of them. The other one takes us all the way to this side. Right? Let's get that a little bit better. Trying to draw this as good and as quick as I can. So I've got one here, and I've got 2 on the bottom as well. Okay, 1 here and 1 here. This should be 4. Okay, the way that we're going to figure it out is we're going to find the area of the base. So for any volume, it's going to be that area of the base again, so we need that. And we're just going to multiply that by the height. Okay, let's make sure that works. Let's find it here. If I think of, let me get rid of, I tried to do something last time I tried this video, and it ended up deleting the whole video. So that's why I'm a little frustrated. Let's look at this as my base. It's 2 times 1, so if I'm looking for area of the base, 2 times 1, which is 2. And the height, the distance between the bases, is also 2. So for volume, I would have 2 times 2, which is the same 4 cubic miles that we found before. Meaning that there's 4 cubes that are 1 mile by 1 mile by 1 mile that would fit inside the shape. Not too bad. Let's see how we do here. Same 4 problems, just finding something different. Let's treat this as our base again, just because it's highlighted. That's kind of what they're meaning for you to do, but you don't have to. This square down here, or back here, is 8 by 8. So area of the base is 8 times 8, which is 64. And the distance between the 2 bases is 10. So the height is 10. So volume, 64 times 10. Anybody agree that sometimes it's a little bit easier? Make sure that we're knowing that that's meters cubed. Again, I'm thinking about like how much water is going to fill this cube up. It's not really a cube, but this rectangular prism. Let's use good names. Okay. This one, let's kind of do the same thing we did before. We could go back and steal those same answers, but I'm just going to make sure to do them so that I don't steal the wrong answers. This base down here is this 6 by 12. It's the same one that's up here. 6 times 12 is 72. And a height of 12 miles also. So for this, I need 72 times 12. Which the volume, I should have wrote that, 72 times 12 is 864. And those are cubic miles. Next one, I'm forced into what the base is by the shape of it. It's a triangle. It's that same 6, 8, 10 triangle where the area of the base is 1/2 the base times the height. Now I'm confused. 1/2 of 8 times 6, which is 24. Okay. And then the height, the distance between the two is 7. So volume equals 24 times 7. $168, and those are yards cubed, cubic yards. Okay. Next one, we've already done this. I know, it's okay. 1/2 apothem times perimeter. So now we kind of need to find all those anyways. But you can see if I ask one problem that asks for surface area and volume, there's a little bit of little less work that you might have to do. I built these the same and with the intention of using the same answer. So I am going to steal it. It's 374, right? 374 or 347? Again, don't steal the wrong answer. 374.4. 374.4, and the height is 5. And when we do that calculation, we get a volume of 1,872 cubic kilometers. All right. So that'll be it for today. Make sure you put any questions you have over on the left. Make sure you write these formulas down. Put a star by them. Put a big box around them. Put what the capital B, what the capital P, what the H really means. Those are very important. Otherwise, have a great day, and we will see you in class.